Hi everyone, I am Pravalika. My new ID is TN567. In this video, I am going to explain about my LSTS homework assignment 2. Uh, this is the command which I have used to run the code for the first part of my code. I have read the sub query dataset and subject dataset successfully, and I have printed the first 15 fragment before sorting. I have also calculated the time taken for searching for first 5k elements within the query dataset. It took me about 1.85 hours to search for the first 5k fragments. It took me about 3.70 hours to search for the 10k fragments. Uh, Likewise, I have estimated for 100k and 1 million fragments to search within the query dataset. Based on the time which I have got for searching 1 million fragments, I have estimated the time um, for 3000 million fragments, which will be approximately 126.64 years. I have printed the first 15 fragments of the subject dataset along with their indices. While coming to part B, this is the command which I have used for running my code. In part B, after sorting the query dataset, I have read the subject and query dataset into my memory, and I have printed the first 15 fragments after sorting. I have also calculated the time taken for searching the first 5k fragments. And so after sorting, it took me about 132.68 seconds to search for first 5k fragments. It took me about 132.7 seconds to search for first 10k fragments. Took me around 132.86 seconds to search for the first 100k fragments. Took me around 1328.66 seconds to calculate for the first 1 million fragments. Based on the above, I have estimated time for calculating the searching for the 3000 million fragments, which is around 46 days. Well, coming to the approach I have used, I have read the both query and subject dataset successfully into my memory. I have also compared the uh, fragments within the query and subject dataset by using linear and binary search. I have used merge sort to perform the binary search algorithm effectively. Well, coming to my code, this is my .h file which I have used it for running the code. Here, this is the queries AR class which takes the file paths and reads the data. Reads the data present in the query dataset and subject dataset, and it compares the data within them. It also prints the first 15 fragments within the dataset. I have used image function to perform the merge. Successfully, I have used merge sort to perform the sorting before doing a binary search algorithm. While coming to read data, it will read the data which is present in the file path mentioned. I have used a sort function to sort the all the fragments which are present in both subject and query datasets. While coming to linear search, we iterate to the when we iterate to the linear search, we search for our target element in the query dataset sequentially. If it is found, then it will return true, otherwise it will return false. While coming to binary search, before perform binary search, we perform the merge sort to efficiently perform searching. And then while performing binary search, we sort the after sorting, we get the middle element after the sorted list, and then we compare the fragments with the middle element present in the sorted list, uh, and then narrow down to the left and right half of the list based on the comparison. While coming to the this my genome .cpp file, which is my main source file. Here I have used a read subject data function to effectively read the data, all the fragments which are present in the query and the subject data sets. And then I have used print subject data to display my fragments. Uh, while coming to the issues and issues I have faced a file reading issue to read the large data sets effectively. I faced a problem with that. I have also faced a problem with memory allocation to allocate memory for large data sets. And fragment comparison is one which I have found difficult. I have overcome this fragment comparison issue by performing merge sort in, in my code, so that I can perform binary search easily. I have also worked on this memory allocation issue by reducing the overhead of memory allocation by dynamically allocating the memory. Thank you for giving me this opportunity.